it has changed an awful lot. And it's currently changing very rapidly. Like 150 years ago, we started looking at stellar spectra, and I think probably most of us in this room know that just by looking at stellar spectra and trying to organize them, that is essentially what led us to unlocking an understanding of what a star is, where the elements in the universe originated, and all of that. And everything associated with our understanding of stars and stellar evolution and galactic evolution and all of that came from looking at stellar spectra. I've got a quote here. I looked it up this morning as I was preparing my thoughts to open this discussion from Vesto Slipher in 1913 on the topic of spiral nebulae in the context of his measurement of the radial velocity of the Andromeda Nebula. He said, "No attempt has, to my knowledge, been made to determine the radial velocity, although the value of such observations has doubtless occurred to many investigators." He measured the value of minus 300 kilometers per second, and he says that and then he ended it was like a one-page paper, and he ends it by saying that the velocity of the first spiral observed should be so high intimates that the spirals as a class have higher velocities than do the stars, and that it might not be fruitless to observe some of the more promising spirals for proper motion. So just looking at things is sometimes quite useful and changes our understanding of things. And as we now know, Slipher was right, and this was really the key to the unlocking our understanding that we live in an expanding universe, came from that first observation, and the thought that maybe we should do more of that. So observations like this transformed our understanding of the world we live in during the 20th century, and they transformed the fields of astronomy and astrophysics in the process, or the field of astrophysics was born in the process. An astronomy class in 1875, 150 years ago, or in 1913 was a completely different class from one that's taught in 2024, because the field was completely different at the time. And we continue to make similarly major advances. Skynet and Las Cumbres Observatory have broken down barriers to observing and post-processing of data, so that not just professional astronomers, but students in our classrooms, they have the ability to collect their own data and actually do science with it. LCO has spectrographs that professional astronomers can use to observe supernova candidates and confirm that they are supernovae very quickly and follow up, and they are really changing our understanding of stellar explosions. Skynet has robotic radio telescopes, or robotic radio telescope at the moment, but there soon will be more. Since 2018, Gaia has completely transformed everything. What we can do because it's given us parallax and proper motion values for every star down to 20th or so magnitude. Rubin is soon to be imaging the entire southern sky down to 23rd or so magnitude in 6 color bands every few days. In a few years, Argus is going to be essentially videoing the entire sky, its entire sky, from wherever it ends up being located at 1 second time resolution and 1.4 arc second resolution, and also with colors. So it's going to completely transform what we know about the universe, being able to just have constant video streaming all night long from wherever Argus is. James Webb and Euclid and Roman. There are also solar system astronomers, people who study that. So the list goes on and on and on. We are generating so much data, and there's sort of endless opportunity for discovery. Our next question, the one that I'm going to come to after we talk about what astronomy is, which I've told you my ideas about what astronomy sort of is, is what should be the main goals of astronomy education. That's the one that ranked the highest. And while I do still want to open the floor for answers to this question, before I do, I wanted to sort of skip past that and follow up with a question that I think should be on our list probably, and it didn't even really make our list, but this is my answer to the question is this question. For every astronomer, there are, on average, I don't know, 100 students. This astronomer has about 1,000 students a year. How do we make the most effective use of this ratio in advancing our understanding of the universe, leading students to discoveries like the ones that Williamina Fleming and Annie Cannon and Henrietta Leavitt and all of them made by looking at data? We have lots and lots of students who we can feed data to, or they can pull it off of the internet, and they could be making discoveries like the Harvard computers did when looking at spectroscopic data, developing their skills with technology, et cetera, learning to program in an exciting learning setting. So Ahmad organized the AstroCodex collaboration at Yale. A few of us were there a couple of days ago, and the idea is to build a living repository of computational astrophysics tools, things that people can use in classrooms. So we're doing this sort of thing. So that's a really exciting collaboration. So I think things like that should be our goals. And I think goals like that, or involving students in telescope instrumentation projects and all of that, are what make astronomy a gateway to STEM, which is another one of the questions that we're going to come to here in a minute. But this isn't really about me standing up here telling you all what I think astronomy is about. It's about having a discussion about what we all think astronomy is and what its goals should be in astronomy education. And so I have invited Lisa Story-Lombardi, the director of Las Cumbres Observatory, and Brian Kloppenberg, the executive director of the American Association of Variable Star Observers, and Artist Harold, an education specialist from Rubin Observatory, to tell us what their thoughts are and open the questions up to the rest of us. So I'm going to start by asking them to give us their answers, and the rest of you raise your hands, throw the mics around, and say something as you like. So the first question is this: if people have thoughts on what is astronomy, and is it what professional astronomers do? Is it the study of anything that can be observed with a telescope? Is it all about understanding what the seasons are? How has astronomy changed over the past 150 years? So any of you, Lisa?
Is this on? Yes. I thought this was actually a pretty hard question. I figure there's nobody in the room who thinks it's what professional astronomers do, but I Googled it. And one of the definitions was everything we can see above the Earth's atmosphere, which actually isn't bad for a short sentence. There's a whole lot more involved there. And there were things in the question, what is this? Does this relate to teaching seasons? Yes, because celestial mechanics gets you to seasons and things. It's also a route to the history and future of everything in the universe. And it also provides us the night sky, which is a connection to the natural world. I decided physics was a lot easier to define. How does the world work from the smallest to the largest scales? But astronomy is a great gateway to do it.
Yeah, I kind of subdivided the problem into two different ideas. The first of which is what is astronomy, and then the second one is what is astrophysics. I think if we look back over the last 150 years, we can really see that astronomy is not anything close to what it was in the past. I mean, the Rutherford model of the atom was published in 1911, and that really let us understand how modern atomic theory actually developed and understand the spectra that Daryl was just mentioning a few moments ago. The distinction between astronomy and astrophysics has classically been one where astronomy has basically just been observational in nature, and then astrophysics has been attempting to interpret those measurements into some physical model that understood the universe. Now, where are things going to go? I guess there's another question that'll come up later, so I'll save that for a little bit later on. So, Artis.
Okay. I approached this a little bit differently. I started thinking about what is astronomy in the context of the courses we teach. And I have the privilege of working with instructors all over the world, and many of them in the United States and Canada. And there's a great diversity about how we teach our intro astronomy courses. There's not one like common strand. And part of it is due to the experience of the instructor. Part of it is due to the resources available at that particular institution, right? But there's another interesting part I want to add to these two good definitions of astronomy to start with, and that is some instructors take astronomy to also mean space exploration. So they have entire units on rocketry and propulsion. Some astronomers or some astronomy teachers really focus on solar system in the sense that we're looking at the geological and climatological processes of the planets. And we have access not only to instrumentation on the ground, but we have access to instrumentation on spacecraft. And so we have some amazing abilities to do remote sensing and even spectroscopy on places like Mars.
Thanks, Artis. Does anyone else have an answer or something that you want to say to this question? Is everybody just ready to move on? Oh, yes, please.
Grab a throw mic.
See if it works.
Joe. I think those were wonderful answers. Thanks so much for sharing. I just wanted to add that when I think about teaching astronomy, I think about teaching the astronomical enterprise. So the people are making, constructing whatever astronomy is. And so part of my coursework is like about the humans who are creating that knowledge, just so it's not just content or skills, it's also people do this. Yeah. Who do I go to? Or someone? Keep it in the section I hear, okay.
I can't, this thing doesn't work. It's like,
I'm trying to listen to what they're saying.
okay, I'll be loud.
That's confusing, sorry.
So I'm old enough to not really remember when astrobiology was a term. And now, so I tell my students, I tell my students, very well. It's also biology, but sounds like
Sounds like it.
It's just, there we go, taking what we can study in a lab here and being able to compare in space sometimes and sometimes the other way around. Thank you. I'll be here all week, not with the microphone.
So I can be loud, hopefully. I come from a heliophysics background, so I also include things like space weather, the aurora, the space weather storm that just happened. And so, I'm more of a planetary person, and I do research at NASA. So I also tend to include a lot of things about, NASA and what NASA has done for us. And I do a lot of things like, I include things like Cassini and the missions and NASA missions and why, government dollars or your 0.001% of your government dollars go to NASA. That's part of why do we explore space and why do we do this? Why do we need Hubble? Why do we need Webb? Why do we do these missions too, so that they understand why studying space, the planets and space weather and things like that are important too. So I do, like above the atmosphere, I take that literally. I love your shirt. Thank you.
I want to, I really about stuff, the cosmology, galaxies, and students tell me they want to go outside and look up. So I want to give students as much as they can without a telescope. What point, as much as they can without a telescope. For example, understanding the seasons and at what point on the eastern horizon the sun rises on any given day, what point on the western horizon they set, because those are things that they can do themselves.
Hi. I might teach a different type of school. I teach multiple different types of astronomy classes. So the answer to the question to me is, who am I teaching to? Because if I'm teaching to people who are not interested in science whatsoever, it's going to be more about the usefulness, as some have mentioned. It's going to be about how it relates to Earth. It's going to be about our neighborhood, the solar system. And the other courses I teach that are interested, students who are interested in astronomy or at least in some kind of science, I'll teach it a little bit differently. It'll be more about how astronomers do things, photometry, spectroscopy, solar weather, like all of that. But for the students who are not interested in astronomy or who are not interested in science at all, I teach it like I'm talking to future voters who are going to be influencing funding and who are going to be raising children who might be interested in astronomy. And I don't want them to hate or not understand why astronomy and physics are so important to our world. So that's how I teach. And that's what I think of as astronomy for those type of students.
I'm just going to interject a little summary here from what I'm hearing. So like if you teach an introductory physics course, there are certain things you have to teach, right? And there's a prescribed curriculum. But what I'm hearing here, everyone teaches introductory astronomy a little bit differently, sometimes a lot differently. So what's really unique about the courses we teach is perhaps, and here's a dangerous idea, and I'm sure we'll hear again, the content doesn't really matter. It doesn't really matter what we're teaching, but maybe something else does.
So I come from a different background. I do particle physics and cosmology, and I've always been interested in astronomy because I think it's the first science that we as a human started exploring, right? So when I teach a class, I have two-prong approach. First, it's a historical approach where I want to tell my students the journey that we started like a few thousand years ago, staring at with our naked eyes, and how much we have made progress coming to this point in time. And the other approach is I want my students to take away, once they get away from the astronomy class, I want them to be a lifetime learners in a sense, like when they hear news about they found a galaxy that was like 13 billion years away, light years away means like they got to make sense of what the news is about, right? When they hear in the news like they found a planet that has water in it, as a layman, it's kind of nonsense, right? You hear about the story, you are watching at this object millions of miles away, and you're claiming you have found water on that planet, right? And then like I want for them to make sense, like, okay, you can do this by just looking at the light. So I want them to understand the basic physics, how the astronomy is done, and so they can take away and tell others, like, this is what they are doing. So, thank you.
Thanks. So I'll come over to you, but maybe I'm going to go like this first.
Tony has great differing opinions.
I'm coming over there right now, but I'm going like this because I'm seeing that the conversation is really kind of morphing into this question here. What should be our goals with astronomy education? I'm wondering if that's maybe what you're commenting on. You can still answer the last one. What I was going to say is maybe what I'm hearing overall is that astronomy can be defined as whatever the hell we want to define it as in our minds, and we don't have to actually put words to it.
So I'd agree with that, but suggest that we need to do that. That's our job here, that we described astronomy as this umbrella term that can mean all these different things. It could, astrophysics is part of astronomy, space science and space physics, which I graduated with a PhD from a space physics and astronomy program, and I didn't know what space physics was and how that was different until I was actually there. The astrobiology is a separate thing. Space exploration, we know that space exploration, going to the planets, isn't quite what we think of as astrophysics. They're separate things, but in an intro to astronomy class, which most of us are teaching, we have this big, wide umbrella. And so I would suggest that perhaps that as we're having this conversation, we be a little bit more specific in our language, that we're not communicating if we don't say exactly what kinds of topics. And I want to reiterate what was the comment over here, who we're teaching, because it's a huge difference between teaching the people that aren't interested in science, and we're trying to get them to not hate science when they leave. If we have made them do as much math as possible but hate science, we have shot ourselves in the foot as scientists for decades to come. And we've done that for years. And so I would, in astronomy, I would suggest we consider this an umbrella term, but in our conversation, we might want to be more specific. Are we teaching spectroscopy? Are we teaching use of that language in these conversations for the next 3 days? Because that'd be helpful.
Can I be specific?
Yes.
Okay. So we all heard Enrique Gomez, and we all heard the joke that sociology is really psychology, and psychology is really biology, and biology is really chemistry, and chemistry is really physics, and physics is really math, right? Because that is the student experience. And then the question is, what is astronomy? And I want to suggest to you that astronomy is really data science. That we can actually use the Astro 101 experience as essentially a Trojan horse to introduce to a large population of students how to make meaning of exceptionally large data sets. And what Daryl was saying at the beginning, that now it's possible not just to use robotic telescopes, but use archival data, to use Gaia data release, to use these things and teach these students how to find creative ways of representing these very large data sets so you can extract a tremendous amount of information out of this and make meaning out of this. So I am wondering if for purposes of being specific, right, as to what is it that we can actually now do in Astro 101 that could actually have a very positive salutary effect in the student population and the university experience is, maybe we should explore essentially this frame of data science. And that's it. Thanks.
Okay, so then in that sense, one of the big goals would be making sure that students are actually able to access those data and be able to do interesting things with them. Anyway, but I did change the question, and then I haven't come back to our panelists, who I invited here to get their thoughts. So I want to ask them, before moving on back out to other comments, to get your thoughts on what should be the main goals of astronomy education. Does anybody feel like going first?
Yeah, I just to kind of dovetail into the last conversation and provide a logical segue here, right? I think there's probably 3 groups of people that we need to consider in the general idea of astronomy education, right? There's the Astro 101 non-major students. Then there are the astronomy students that would potentially go on to get, an advanced degree in astronomy. And third, there's also the general public, and I'm going to cover them kind of in the reverse order. I used to work in a planetarium, and the number one thing that people would ask me is, where is the North Star? Where is the Big Dipper? Right? And what are the stories that come along with the constellations? My favorite story to tell was the classical story involving Cepheus and Andromeda and, all of the rigmarole that happened there. And it provided, it was a teaching moment through storytelling. And despite the fact that those things couldn't, they may not have been real, depending on what you want to believe, they do offer a way of conveying some knowledge and some information to people, and then people remember, oh, that little W thing in the sky, I remember who that was, right? And it provided them with a general way of navigating through just through the sky, so that they could actually go and look up and try to learn things, and then perhaps pique an interest and evolve their general education. then packing up one over to the people that are actually majors, right? We need to provide them with a relatively broad base, especially at the undergraduate level and more specific at the graduate level, of all of the things that they could potentially do in astronomy, because there's probably a good chance that they don't really know what they want to do, right? Some people that I know, they've always wanted to be astronomers and they know precisely what they want to be. There's still a pretty good group of people out there that, oh, I think I'd like to do this, but I'm not really quite sure of what is possible. So, provide a major with some experience in doing, instrumentation building. Provide them with the ability to do some kind of data science activities. Let them go out and do observations, because even if they don't go on and get a PhD in astronomy, they may be employed at a major university or a smaller facility operating telescopes. And then finally, backing up to the people that are just non-majors, right? They need to have access to some knowledge that allows them to be able to interpret what they're reading in popular press in the future, as well as just a general appreciation of what are the things that we could do in astronomy. And so we've heard from many people in this room that they teach astronomy differently, right? You have people that are very observational focused, people that are data science focused, people that want to show the actual process of learning. And it's more or less up to the instructor in those lower level things, but there's probably some core group of things that we should be teaching, generally speaking, to address the breadth of knowledge that you could impart in a general Astro 101 course.
I actually really like this question. And what it made me think of was, my first thought was, the world doesn't need more astronomers. And I was really surprised as a graduate student to learn that the substantial majority of my classmates, and this is born to be true throughout my career in the last 30 years, knew they wanted to be astronomers when they were 10. And as you say, there's things we should provide and we can provide for those folks. But it's only in the last few years I've really figured out the most important group is the group other folks have been talking about. They're not interested. And I discovered astronomy, I discovered physics, I discovered science in the giant Physics 101 lecture course for majors when I already had another degree. Anyway, so strange path. But I think and I've learned this watching the people who do education with Las Cumbres, is I think the greatest thing we should do with astronomy education is create scientifically literate people. And for the ones that the bell goes off in their Astro 101 course, oh, I can do science. I think that's it. That's really, that should be the goal. And then all the rest of it, all these are great things in terms of what we can do and that are just good in general, but.
I absolutely agree with you. I remember my first experience of taking astronomy courses in college, and it was much my impression that I had to prove myself that I was good enough to be in the club. And it was kind of like the pre-med experience, If you jump through enough hoops, we will admit you, perhaps. And I think we really need to turn this completely around. We need to invite everybody to participate in astronomy. I mean, so many of our students take this course because they want to be inspired. They want to approach this, and they think for some reason astronomy might be a little bit more approachable than some of the other sciences. And one of the things I think about all the time is, as several of you have mentioned, we are trying to build a scientifically literate society, but the first thing we have to do is give them the skills to be able to think critically, because sometimes it's a scaffolding process. It's not that they can't do it, it's just that nobody has held their hand and walked them through how to think about data analysis, how to take apart a problem. But secondly, we really need to be there to give them a sense of self-efficacy, that they can do science. Because really what that translates into in the future is they can look at authority problem in our country and come to some conclusions and decide how to vote and decide who they're going to support in terms of where their money goes, where their vote goes. And really, most of our population are not going to be astronomers. In fact, many of the astronomers that I know that went through college and got a PhD have now moved on to much more lucrative careers with coding or data science or other things, right? So the focus of our population are really just regular people.
If I can ask there, how do you create a scientifically literate population? Are we trying to fill their brains with facts? Are we trying to fill their brains with the experience of doing science?
Doing science.
Thank you. That was easy.
Okay, I wanted to bring up another point, I think, with students. You know, with regular students, they don't even know what astronomy is, and many of us, we're teaching in an urban environment. When they look at the sky, they see nothing but light pollution. It's never come up in their education. They're worried about surviving the day-to-day. They have jobs, children, and all that. So I think a lot of it is also, why would it matter to them? Why should astronomy matter to them? So we kind of need to create a little bit of a buy-in here. So maybe the connection, well, you are astronomy, you come from the universe. That's why it matters. And then, of course, leading them to the science and the scientific literacy.
So something I thought of that kind of came up when how we connect stories to the skies via constellation, and then the bringing up of light pollution also kind of hammered this home, is astronomy can inspire wonder. For ages and ages, we have looked up as a night sky as collectively as human beings and been like, wow, and just being at a loss for words. But like, as someone who has lived like within an hour of a major city for pretty much my whole life, whether it be Chicago or Indianapolis, yes, I can see stars, but not truly that many. And then I went to Kit Peak when I was in undergrad, and I was like, whoa, there's so many more stars than I ever thought was possible. But then last summer, I had the opportunity to visit Thailand, and me and my dad, we flew into Bangkok, and the first night we were there, we were sitting out at the pool, which was outdoors at our hotel, and I looked up and I could see 2 stars, literally 2 stars. And I was just like, this is the status quo for a lot of people around the world now, and many people can't see skies like what we can see, and so they're losing that sense of wonder that we used to have as a human species. And I think if we can bring back that wonder, we can inspire people to be lifelong learners. And maybe they don't necessarily have to know everything there is about, say, astronomy, for example, but they can be curious, and then they can maybe be motivated to fund things that allow people who actually, like us, who are able to do those observations to find out the answers to the questions that they have.
Awesome. Okay, so I'm going to go Calais, and then here, and then come to you.
Counterpoint to some of what some people have said, and one thing that we're going to talk about later, it was number 3 on the content questions, is what are your course prerequisites? Many of us have struggled with that. I have also 2 different astronomy courses, one targeted at kind of the non-STEM audience that many of us are talking about, and another targeted at students who've had physics. I struggle with students who haven't had physics wanting to take that one and being in way over their heads. and then not achieving any of the goals that we've been talking about here. And they want to be invited. They make all kinds of arguments about why they should be, despite not having the prerequisites, and why they shouldn't have to take the other course that is targeted more toward their level. And so it's kind of this, it's a tension. I've been writing a lot of emails lately to people telling them, please don't take my class, kind of shutting them out in the way that is negative to them, to their inspiration, to their feelings of self-efficacy. But I would welcome them once they take the prereq classes, and I would welcome them in my other class as well. So yeah, it's not a question that has an answer, just a random comment that there's a lot to think about in kind of throwing the door wide open, maybe not too wide.
I agree with what's been said so far about teaching as the last course in science that some of your students, or most of my students, will ever see. And I have to consider something I read a few years ago, that about 30% of those students will end up in a classroom someday. So not only am I trying to teach them how to think like a scientist and how to appreciate science as a decision-making process, I also have to consider, how am I teaching them the methods of science teaching? What am I modeling for them to do later? And that's a very important consideration for me, as I'm considering, what activities do we do? What lessons do we do? What things do we not bother with? Because honestly, it's just grunt work. Why would I put my students through that? So we don't.
Thanks. Okay, and then I'll come to you, and then are we, after this, okay to move on, or does anyone else want to, seeing a hand?
I want to reiterate the comment on lifelong learning that was made up here a few minutes ago, because we've only got them for, at most, 15 weeks, right, for a semester, and they're going to live for another 60 years on average. And so what we can try to teach them, and the notion of science literacy is very important, but if they don't want to read, then science literacy won't make a difference. If they're not inspired to actually care about astronomy such that they see the headline and read the article, then it's lost. We've lost the opportunity. Inspiring them to both want to read articles and then to be able to read it. But if they don't want to, they're not going to. And to be able to do science on their own, to do astronomy on their own, if they choose to. And here's where I would differ with, but this is a later question, as to what technology they use to do that one. That I would argue pretty heavily that them being able to do stuff with technology they own and observing the sky directly is probably more important for non-majors. For majors, that's a separate question. But for main goal for astronomy education, inspire them for lifelong learning, give them some of the skills, they can pick up the rest on their own later.
Thanks.
I was going to pick up on kind of what Tony said, that I think most intro to astronomy classes focus on, almost could be called intro to astrophysics, right? They're focused on the, orbital motion and the physical aspects of the universe. And yet, I think many students come in, what do they think they're coming into when they come into the class? They think they're coming in to learn, the stars and the constellations and things like that. And to Tony's point, what do they take away? They don't, I'm not dismissing, obviously, the importance of the physical aspects, but maybe, the approach to a non-major, giving them a little bit of what they are interested in isn't so bad, and giving them, something a little outside the box that they can take with them, that they can know at least the major constellations in the skies, and that leads to, things like, orbital periods and things like that. So
Thanks. Okay, so I think I want to, do a couple more on that topic.
Mine's just brief.
Yeah.
I teach, I am actually from a very rural community, and then I went to a very urban community when I was older. And part of my teaching, I've encountered this, that's important for teaching astronomy, particularly for those who are either new to it or are not interested in science. And a big goal to me is addressing those conspiracy theories that students have from home, like, why don't we go back to the moon? Did we actually go to the moon? Like those kind of questions, like address things that they might have conversations with their students, or with their parents and family. So like, that's a big goal for me for introductory astronomy. Does somebody have over here? Somebody.
I just wanted to add, this actually ties into your comment too, but coming back to the idea of self-efficacy, I agree that distilling the idea in students, like having them come away with the idea that they can do science is a big goal of astronomy education. And also, I feel like it can't be the only goal. And I say that because I had an experience last semester where I asked students to do quiz reflections where they could revise their answers to quiz questions. And I also asked them, how confident are you in your answer and in your ability to answer a similar question again? And I had a number of people who did the revision incorrectly and answered, yes, I'm very confident in my answer, and yes, I could 100% do it again if asked. And I think that they did come away with a sense of self-efficacy in a dangerous way. And so, right, like maybe this has to do with like conspiracy theories as well, right? If you were to extrapolate that to the extreme, right, we want people to be able to think through problems for themselves and form their own opinions with some sort of caveat, and I don't know what that caveat is, but like, how do we have them form a sense of self-efficacy in a accurate way, I guess?
I would like to just add to your comment that I think I've thought about this a lot too. And I think the key is they have to be collaborating. They have to be working interactively with someone who will argue against them. And because that's when the juice starts flowing and you start re-examining your motives and your way of thinking. And this is a major shift in, I wish I would have known this more when I was teaching actively in the classroom instead of now. But the major shift I see is it is just so much more effective for students learning if they are, you know, doing the think, pair, share thing, or however you want to do collaboration, discussion, analysis. When, you know, my classical education is I sat in a lecture and took notes, and I think a lot of us probably did. But to have a room like this, right, where we could interact with each other, where we could discuss things, where we could get on Discord and write comments down, I think that's part of what we need to do to help guide them along so we don't get these conspiracy theorists.
Yeah, that's great. I'm going to come right back to you, Artis, actually. So I like how we're coming to this sort of an understanding that maybe that astronomy is a very, very broadly and ill-defined thing. It's sort of whatever we make of it, and that the goals of astronomy education are maybe even less well-defined and very extremely nuanced and really depend on each individual person and not content necessarily specific, but really there are all of these sort of things like getting people voting and understanding science and all of that. And so I think that sort of segues nicely into this next question of how does astronomy fit into other STEM disciplines more broadly, and is astronomy actually a gateway to other STEM disciplines? And maybe if we can just shift our focus, and if you want to come back with your with your question. We can. Oh, sorry. I thought I was. Come back to is astronomy actually a gateway to other STEM disciplines? So I think we started with Lisa and then Brian and Artist. You.
It can't be, right? I mean, I don't think it is the gateway to STEM disciplines because everyone has different interests, but certainly it could be a motivator for a student who comes into a class feeling like they can't do any kind of science and then leaves our class feeling like maybe they can. That's my short answer.
So in the way that it gets people thinking scientifically and gives them some self-efficacy.
It gives them a little bit of a skill set.
Yeah.
You know, that
yeah.
we build a basic skill set for how to think, how to analyze, how to dissect a problem.
Mm-hmm. Yeah. That's great. Lisa.
I actually don't have much to add to that. I think it is, a gateway. Even if you live somewhere that's incredibly bright, everybody's seen the moon. That it's just less scary, and it's not. Well, there's still some imagery of the guy in the white coat with the telescope pointing out of the dome with the lights on, kind of image of astronomers. But it's less so than physics still is. So I think it's less scary for people who don't know what any of this is. So yeah, I think I agree with what you said.
Yeah, and Brian is the executive director of this massive amateur community of people who find astronomy interesting and not as scary as is there an amateur physics community that's anywhere near?
There are people that have like they can make chips at home. Like there's amateurs in every single weird hobby that you might possibly imagine. So maybe I'll dovetail off of that, right? For how astronomy fits into other STEM disciplines, I think it really is kind of like the endpoint where you get math, you get physics, you get observational techniques are all being applied, and so it really is assembling those things, at least within an Astro 101 context. If you branch out, it can serve as an inspirational point for people. Most of the AVSO members that are within the United States, we see them growing in interest around the age of 12. And then they kind of peak in their early 20s, and then they disappear, because life happens. And then finally, like in their 40s and 50s, when they have enough time and enough money that they can start doing astronomy again as a hobby, we see them show back up again, and then they peak kind of in terms of numbers in their 60s and 70s, and then life happens again. But we don't see that trend outside of the United States. For example, in India, you basically see people come in at the age of 12, and they're there for the rest of their life. And so there's some regional distinctions that you can actually get within that area. But I think in terms of astronomy being a gateway into other STEM fields, within the professional level, right, like you just mentioned a couple moments ago that most people that come into astronomy don't stay in astronomy, they go elsewhere. And so you learn a lot of valuable skills, especially if you're a major that are applicable in a wider range of areas than just astronomy.
Thank you.
Can I just say that amateur astronomers are amateur the way Olympic athletes are amateurs or the way they used to be amateurs? I have a friend who got telescope time on Hubble because a bunch of amateur astronomers got up at like 3 a.m. and stared at Uranus and took amazing pictures of Uranus with their telescopes around the world. And he was able to get time on Hubble to look at Uranus because a bunch of amateur astronomers got up in the middle of the night and took pictures with their telescopes. And he, as a professional planetary scientist, was able to do that. So shout out to the amateur astronomers that are not really amateurs. You know what I mean? Like these people are dedicated and amazing astronomers.
Yeah, that's the distinction that, like, when I use the word amateur, I use it in the form of love of, as opposed to unqualified. And really, it's paid for professional, non-paid for
Olympic
amateurs.
athletes are amateurs,
Yeah.
like, or the way they used to be, now they're professionals, but the way they were like in the 80s and 90s, like he was able to get telescope time because he put a call out to amateur astronomers and they got these pictures. And yeah, so when people say amateur astronomers, I'm always just like, you people are just crazy. Like they get out at like 3 a.m. and they're out on their telescopes. And my students, and I'm not a telescope person, they're amazing. Shout out to amateur astronomers. Anyway.
Yeah, so I just had one comment, which was, I think that maybe instead of thinking about it as a gateway into STEM disciplines, a lot of what I've seen teaching or being a TA in an 800-person major, non-majors astronomy course is that it's a gateway into like critical thinking or a gateway into undergoing the process of developing mental models about the world or seeing something that you don't understand and then undergoing a set of things to understand it. And I think that that's kind of one of those things that of the sciences, a lot of the things that are covered in an introductory astronomy class, like the phases of the moon or other sort of seasons, celestial things, can be understood with a mental model that's mostly like geometry, as opposed to having to resort to more and more complex models that get deeper into physical processes and things like that. And so in that sense, I think as a way of teaching people to think that way can be a gateway to where it's not just other STEM disciplines, but just all sorts of other things. But that also there's this kind of wraparound that I've seen happen, which is that I've known people who were undergrad majors in physics or chemistry or engineering, other STEM fields, that were getting either overwhelmed or just like bored of that core. And astronomy was actually providing a application for the thing that they had chosen to study that was like more interesting than what they were doing before. And so if they're like, I'm interested in chemistry, but astrochemistry is a really cool application of it, or a place that we can study chemical processes that don't happen on Earth. Same thing for physics, same thing for engineering. So I think in a way it can be a gateway to other things, but it can also be like the finishing point where you could go into physics and then actually end up in astronomy. So it kind of goes both ways.
Yeah, or like I see that so frequently with computer science majors where, they'll take my class and, oh my gosh, I was just about to drop out of university because computer science is so friggin' boring. Just programming nothing. And then they start programming for astronomy, and it's like, wait, I actually have a useful skill, and it's fun.
Sorry, I keep talking. So 2 comments. One, amateur astronomers are where it's at. For various reasons that we'll get into, I wasn't allowed in the physics class at my high school. So sky parties, if anyone's ever been to those, where the amateur astronomers collect and they just gather a bunch of telescopes in an airfield somewhere and point at the telescope, and anyone can come, and there's talks and stuff. If you've ever been to a sky party, they're amazing, and they're the reason why I went into astronomy. And then secondly, with the gateway, as my neighbor Kenneth said, are we the marijuana of science? But in all fairness, I had to give you credit, that was a good one. But in all fairness, we kind of are, for a lot of high school schools, the kids who don't do well in any of the classes tend to get thrown in what's called Earth Space, which is astronomy in high school for a lot of high schools. And so we kind of are, because the only, in my state, I'm from Indiana, the only science that's required in high school is biology. And that's it. So if they take another science, it's probably going to be Earth Space if they're not interested in physics. And for those type of students who didn't know they could be good at it, this is an opportunity to show them they could be some kind of scientist. And astronomy is very well positioned to be somebody that can get interested in a lot of different sciences. Like some people were mentioning, they discovered they were good at coding because of astronomy. Biology, someone else mentioned biology being, astronomy kind of fits all the gloves as far as STEM goes, and you can literally take any other science and add astronomy to it, and it'd be a relevant field. So like, definitely is kind of not only a gateway, but also if you're not interested in STEM, or if you don't know if you're interested in STEM, astronomy is a great way to find out.
So I think astronomy can be a fantastic gateway into STEM, but I think we have to be a little bit humble about we as astronomers, however you define that for yourself, we are not all of STEM. I found this in the past few years a lot working with computer science students, sort of this pressure relief valve for them. They're getting bored, strung out, but they have a very, very different way of doing quote unquote science than we do. And I found, for example, in projects where they learn. I think it's from day one now. They just plug it into ChatGPT and say, how do I solve this? How do I write the code to do blank? And then I ask them, well, why did you fit a Gaussian here? Or why did you fit this, sigmoidal curve or whatever? And they say, well, because, ChatGPT told me. They know what to do. I think we have to be aware that I use a computer as a tool, but for some people, the computer is the field. And that's a bias that I'm going to introduce into my classroom in the upper division that we have to be aware of. And I think also for students coming into astronomy, we have to be aware that we have different ways of doing science, and not just within the hard sciences, quote unquote, of computer science or genetics or something, but also the social sciences. In 101 astronomy, I spend the first 3 weeks, I don't say anything about the stars as, G-class stars or something. I'm talking all about cultural astronomy. How did the peoples who inhabited this place typically view the world 1,000 years ago? How do we do science over thousands of years? And those students who are coming to that from a American Indian Studies program or something have a very different way of approaching even the vocabulary. And so we can be a gateway, but we're not all things. Even though the divisions between the hard sciences and soft sciences and the divisions within computer science are breaking down and they're very fluid, we're not all science. So I just, concern of humility there maybe, or a sense of humility, so.
Thank you. Dan's pointing at his non-watch, saying that there's 15 minutes left in our discussion here, and that I should go like this, and that I should point to Lisa and ask her, how does or how should the content of a curriculum depend on the audience, and move the conversation on?
Well, I guess my thought on this one was, don't you have to know your audience to provide the right curriculum? So it's basically a question back. And in other words, if you want your students to succeed, not that you want, quote, everybody to pass, but you want them to learn, I would think that the content really does have to depend on your audience. As Calais said, kids really want to take our course, but if they're going to fail, this isn't the right answer.
Yeah, I concur. You have to tailor to the people that you're speaking with.
Yeah. And so, okay.
And I'd just add that you also need to tailor the course to the purpose of the course. If it's a lab science class, it's going to have a math prereq probably. It's going to have a lab component. Otherwise, it's not going to fulfill that part of the program of study.
Yeah, maybe Daryl, do you mind if I hijack the question and turn it around?
Yeah, please do.
Who are typically our audiences, right? So I mentioned, right, there's the majors, there's the non-majors, there's the general public, but I bet there's a little bit more delineation within each one of those categories that would be worth discussing.
Like the non-majors, say, who are STEM majors, and this is, I'm taking an astronomy class because as an elective, but really my field is genetics or something like
exactly.
that. Versus someone who is doing an English degree and has decided to take an astronomy class.
Future teachers.
Future teachers.
That's a big one.
They are some of the most important people that we need to tailor courses to because of the STEM identity, STEM literacy, current teachers, teaching the teachers. Community education, so science, astronomy outreach.
I think the key thing for all these different levels is finding ways to do instead of ways to listen. It's more challenging if you're talking about a group that doesn't have a math background, maybe it's a citizen science group, you're not going to have them doing algebra, where you may have majors, and even non-majors may have them doing algebra but not calculus. But finding something they can do so they can understand what science is. Science isn't a collection of facts that I have to memorize for the exam. Science is a process. It's a hard process, and that's what we need our citizenry to understand before they vote. It's a hard but honest process to find truth.
So I guess another comment that I have, now that we're talking about this in this way, is that one thing that's really neat to me about astronomy is how astronomy in 2024, we are able to make it so accessible to such a broad range of people. I love the lab that Dan does in Opus, where a person can take you set up an observation, it takes 5 minutes, and in 2 weeks' time, you've got images of Jupiter taken once a day for the past 2 weeks, and then you can measure the mass of Jupiter, and all you have to teach them is about empirical laws.
We're going to do it in 30 minutes.
And we're doing that one. Everyone's going to see how that works.
Just a quick side into what I feel like a student leaving my class ought to be able to do. They ought to be able to read and interpret properly a graph.
Yeah.
I'm going to show you some graphing stuff tomorrow that I think is fun. Does anyone else have a comment on this one, or should I move on and see if we got 11 minutes left.
I have a small comment. I think we can also flip this question around in another way. For example, in a course that I teach, I have people who have some algebra background and people who completely hate math. But again, like as a requirement of the course, how do you balance between requiring some algebra skills and not making it too difficult for the others to take away or enjoy the class? So what I started doing in my class at the end of the semester is I give them this term project. And the whole idea of project is, here's what you learned in class. Try to adapt this and try to project this into something you are interested in. If you are interested in history, try to explore some history in astronomy and give me a write-up, right? If you're interested in poetry, give me some poetry, but it has to incorporate elements of astronomy in it. So at least at some level, what we should also try is to give them an opportunity so they can project what they learned in class to something they are interested in. And what I found out is one of my students wrote a poetry about her mom. How would she think herself being in this class? What would she take away coming out of this class being a very religious person, right? Another person wrote a poetry about Laika the dog, and like how the Laika was eventually killed and nobody cared about that, and like things like that. So there are a lot of things that the students can take away. We just got to give them this opportunity so they can take that away from the class.
So that question that answer perfectly segued into our next question, which is really about ways that astronomy can be embedded in other classes, and do people have experience with co-teaching with someone from another department, or classes taught at your institutions where people are teaching another subject and they bring in astronomy content, so things like that, and this is a perfect example of that. Brian, do you want to lead the discussion for the next 8 minutes and 44 seconds?
I'll be quick. Must astronomy be taught in isolated courses? No. Can the tools be integrated into other classes? Absolutely, yes. Great examples. If you're in a space science class, right, you're teaching satellite orbital motion. It doesn't matter if it's an Earth satellite or if it's going around Jupiter, right? You can show that the motion is there. If you're in a chemistry class and you're teaching, you're burning things in the Bunsen burner, right? You bring up an image of the sun spectrum, right? And you show, oh, hey, look, here's the sodium doublet line for the thing you just burned. Here it is in another place. And so there's lots of opportunities to plug astronomy in. It may not be to the same level as what we would normally teach it, but it's possible.
Thanks. Artis, do you?
I'm going to offer a pre-college perspective on this. Yes, we've been doing this forever, right? For instance, in elementary school, most elementary school teachers do not have the luxury of being able to have time to teach science because they have to focus on reading, writing, and math. But you could read about science, you could write about science. And so certainly astronomy gets integrated into elementary school. At the high school level, there used to be a course, many high schools in the country called Earth Science, and a quarter of that was astronomy, or sometimes it's called Earth Space Science. Sadly, because of AP pressure, those courses have gone by the wayside, and primarily what people take in high school now are biology, chemistry, physics, and many APs. But our next generation science standards mandate that we teach astronomy at elementary, middle school, and high school levels. So what's happened at the high school level is astronomy has been parsed into integrating in physics, integrating in chemistry, and integrating into biology courses. Now, in theory, that looks really good. In practice, the physics teachers teach the physics, the chemistry teachers teach the chemistry, et cetera, and they don't have time to teach astronomy. But it can be done. It has to be done skillfully.
Great. And Lisa.
Let's do what Brian said.
Great.
I actually am a high school teacher, and I mainly teach math. And I think that actually the integration here is the most effective tool that we actually have. I am going to teach an astronomy class next year around here, but teaching just the single tool of whatever your subject is not super great sometimes. Like I teach a trig class, and most kids are not super interested in like conic sections, honestly. But if you can somehow say, hey, here's some data, can you come up with a Desmos equation that shows how this thing is moving, then they are using that astronomy knowledge and making math. And also, even if you can get into with another teacher. So last year, we started doing a project with the environmental science teacher dealing with light pollution and also the birds that are running into school dying because they get lost at night or whatever. And those kids actually really start to be interested in these things more when it's not just like, hey, I go into this one room and I learn astronomy. I go into this one room and I learn astronomy. I go into this other room and I learn something else. I think we, at least in the high school, really need to try to work with other teachers and work with other subjects and try to bring all these things together. That's.
Thanks.
Could you raise your hand if you teach about light pollution? Yeah, rock on. That's so cool. Over half of us. So this past semester, I was able to partner with an environmental studies professor, and she and I both teach globe at night in the lab portions of our courses. But did you know that light pollution is not just bad for our ability to see the night sky? That's how it applies in astronomy. It's bad for human and environmental health. And so she was able to gear that project towards the environmental effects. So I'll post about Globe at Night. It's a citizen science project, really easy to learn, and it gets students outside looking at the stars and learning about how it connects to their lives across disciplines. I'll post about it in Discord.
Thank you. Does anyone else want to comment on this one? Yes.
So a couple of things. So in AP Euro, and I am not like a strong advocate of all things AP, but in an AP Euro, they have a section on the scientific revolution, European history. And it talks about Kepler's laws and orbital motion. And one neat collaboration I did once was like have a little conversation with the AP Euro teacher and myself, and I'm giving the astronomy perspective, and he's putting it in the context of the class, of his class, and that was really neat. It was a good crossover. And also, I'd argue that we need to flip this question as well. How can, tools and activities that would be good in a history course or a literature course or an art course come into my class? So for example, there's a great case study through National Science Teachers Association. It's called something like the Moon Landings in Context, Science, Society, and Politics. And it highlights a lot of other things that happened in the 60s. It was a little bit busy at the time. And I played a Gil Scott Heron piece called Whitey on the Moon. I don't know if y'all have heard it, but it's basically saying, things are very bad socioeconomically, particularly for people of color. And, great, we could spend all this money to put some white people on the moon. It became a great opportunity for students to see astronomy in the broader context and think about how it's not an isolated thing in terms of STEM or in terms of broader context. Thank you.
Thank you. This has been a really, really interesting discussion. And so I want to thank everybody for commenting, for all of your thoughts. The Discord, I just looked. I wasn't just looking at emails or anyway, I had a look at Discord just now. There are a few comments on there, but it'd be great if people can continue this conversation. We've also built in a long lunch break, like 2 hours, and the part of the idea there is for people to be able to continue these conversations. So if you want to get together with people over lunch and keep talking, continue posting in the Discord afterwards, then that would be super. But yeah, we've got 16 seconds left, so moving on to the next thing.